Welcome to a new video. In this video we will take a look how to solve inequalities. If this is your first time here and if you want to support this channel, do not forget to subscribe, click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. We need to know what is the interval concept. In order to be familiar with the inequalities, we need to learn the interval concept. For example, here let's say we have a is less than or equal to x and that is less than or equal to b also. If this is the case, then we can show x values like this on a number line. This part is filled, okay, and that part is filled as well. Why? Because there is equal symbol on the right and there is equal symbol on the left. That is why we have those points filled. And if we have, let's say this is the first case and this is the second case. In the second case, as you can see on the B side, okay, there is no equal sign. That means the circle is not filled, okay. If it is empty, that means that B is not included in our solution. But because here we have equal symbol on the left, on the A part, so in A, this part in this circle is filled. And if you look at the third case, on the E side there is no equal symbol. That means there is a circle and the inside is not filled on this part. On the B part there is equal, okay, so the circle is filled on B. And in the fourth case, as you can see, there is no unequal symbol. That means on both A and B there is no filled parts. Let's take a look at an example related to these interval concepts. Okay, in our first example, it says suppose that negative 11 divided by 2 is less than or equal to x, and that is less than or equal to negative 2. And in that case, how many integer values can x take? Well, if you divide 11 by 2, okay, 11 by 2, and we all know that if it was 10, and then that would be 5, and we have 11 divided by 2, so 5.5. And because there's a negative, so I just put here negative. That means this interval, okay, can be written as negative 5.5, and that is less than or equal to x, and that is less than or equal to negative 2, guys. Between those numbers, we all know that as an integer, there is negative 5, negative 4, negative 3, and because there is an equal symbol, okay, here on the right, so negative 2 is also included, and there are 4 integers x can take as a value. Okay, we have a new question here, and it says for x which is less than 2x plus 6 divided by 5, graph the solution set on the number line. In such questions, guys, we need to find the interval of x, and let me write the question first. X is less than 2x plus 6 divided by 5. And because we have 5 in the denominator, just multiply both sides by 5 to get rid of that 5. In the next step, we're going to have 5x less than 2x plus 6. Just send this 2x to the left, so it's going to be 5x minus 2x. Treat this symbol as if there is equal symbol. And do the calculations. And that is equal to, guys, 6 left over on the right. And if we subtract 2x from 5x, we're going to have 3x on the left. And on the right we have, no, that's not equal symbol, that is less than symbol, guys. So there is less than symbol here. And on the right we have 6. And divide both sides by 3 to leave x alone. And once you do it, you're going to have x is less than 2, guys. And suppose that this is the number line. And we have 2 here, okay. That is 2, and because the numbers x values have to less than 2, that means on the number line we should go this way on the left. This shows that x is less than 2, or in other words, as an interval we can say that that can be represented as from negative infinity to positive 2, and because there is no equal symbol, we can just put here parentheses. If there would be like, okay, let me show it here. X is less than or equal to 2. And in this case, we're going to say that from negative 2 to the positive 2, but there is a square bracket on the right. And in this subtopic, we will take a look at the properties of inequalities. For addition, suppose that we have such an equality, A is greater than B, and we can add any real number to both sides. For example, let's say there exists a number C, and we can add that C on both sides here. Okay, so that symbol is not going to change, it's going to stay as it is. For example, suppose that we have 5 is greater than 3, and if we add 2 on both sides, still we're going to have 5 plus 2, which is also greater than 3 plus 2. And once you do those calculations, then we're going to have 7 is greater than 5. And still, as you can see, it is valid. And if we have A is less than B, and still, if we add any number like C on both sides, y of that sign is not going to change, it's going to stay as it is. So again, suppose that we have something like 3 is less than 5, and if we add 2 on both sides, still we're going to have 3 plus 2, still it's going to be less than 5 plus 2. For subtraction, we do have the same thing. If you subtract any number from an inequality, okay, on both sides, then y of that symbol is not going to change. For example, suppose that we have 5, which is greater than 3, and if you subtract 2 from both sides, still we're going to have 5 minus 2, which is 3, greater than 3 minus 2, which is 1. And still, that inequality is going to be valid. And again, suppose we have A is less than B, and if you subtract C from both sides, still nothing is going to change. Let's also take a look at the conditions about multiplication and division. Suppose that we have numbers A, B, which are real numbers, and there is a number M, which is a positive real number. And if we have something like A is greater than B, and if you multiply that inequality by M, which is a positive number, nothing is going to change as well. Again, we have an example here. 5 is greater than 3. If you multiply both sides by 10, okay, still it's going to be valid. 10 times 5 is going to be still greater than 10 times 3. And similarly, if we have A is less than B, and if you multiply that inequality by a positive number, M, still nothing is going to change. Again, we have an example here. 3 is less than 5. If you multiply both sides by 10, still we're going to have 10 times 3. Still it's going to be less than 10 times 5. But if you have a negative number like M here, and then if you multiply both sides of an inequality by a negative number like here, then the way of that sign is going to change. Here it was greater than, and now it's going to be less than, guys. Similarly, if you have something like A is less than B, if you multiply that inequality as well by a negative number, you're going to change the way of the sign. Here it was less than, now it's going to be greater than. As an example, let's say we have 5 is greater than 3, and if you multiply both sides by a negative 10, and that is going to change this sign, okay? Here it was greater than, now it's going to be less than. Similarly, we have here 3 is less than 5. If you multiply both sides by negative 10, then that's going to change, guys. This is going to be in this way. So it's going to be negative 30, which is greater than negative 50, guys. And this is multiplication. Exactly the same rules are true for division also, guys. So we can say that this is for both multiplication and division. So the same rules are correct and true for division as well. Let's take a look at examples related to these properties. Okay, in this question we have an inequality where negative 2 is less than x, and that is less than 3 as well. In the first part of the question it says find the interval of 3x plus 1. So because we have the interval for x as negative 2, that is less than x, and that is less than 3, we need to find out, we need to obtain that calculation, okay? We need to obtain that expression actually. And in order to get that expression, x is multiplied by 3. So let's multiply all sides by 3, guys. And once you do it, 3 times negative 2 is going to be negative 6, and that is less than 3x, and that is less than 9. And as you can see, 1 is added to 3x. So I'm going to add plus 1 to all sides as well. And once you do it, plus 1 minus 6 is going to be negative 5, less than 3x plus 1, and that is less than 9 plus 1, that's gonna be 10, guys. So as you can see, for 3x plus 1 expression, okay, we have -5 and 10, and the boundaries are open. So we can say that the interval of the first part is this. And let's take a look at the second part of the question. It says find the interval for -2x plus 5. And again, let me write the interval for x, and that is -2, which is less than x, and that is less than 3 also. But here x is multiplied by a -2, okay, by a -2. So just multiply both sides by -2. But by doing that, okay, we need to change the way of the signs. -2 times -2 is going to be positive 4. Here it was less than, and now it's going to be greater than. -2x greater than, again, -6, guys. And plus 5 is added to -2x. So here just add plus 5. Okay, maybe don't be confused. Okay, this is -5 at all sides and -5, then it's going to be -5 plus 4 is going to be -1, and that is greater than, no, it's going to be positive 5. So it's going to be 9, guys. Positive 9, and it's going to be -2x plus 5, and that will be greater than -1, guys. So we can say that -2x plus 5 is between -1 and 9, and we can show it like this: -1 and 9, and the boundaries are opened. Let's continue with the next question. Okay, guys, this is our last question in this video. That question is a special type of question, actually. Whenever we have an x something square here, okay, we need to treat the question in a different way. Let me write the interval first: -2, and that is less than x, and that is less than 5. Once you take the square of both sides, okay, let me take the square of both sides. Here we're going to have the square of -2 is plus 4, and the square of 5 is 25. Okay, whichever one is greater, I'm going to write the right side that number, because 25 is greater than 4, so I'm going to write 25 on the right. And on the 25 parts, there is no equal sign, so I'm going to write down that symbol as it is. And I'll put here x squared. Here, because one side is negative and the other side is positive, always put here 0 in such cases, and there's going to be a equal symbol as well. So if on one part is there is a negative number, and on the other part there is a positive number, and if you take the square of that variable, always the left side starts with 0, guys. Suppose that the question is this: negative, let's say 5, and that is less than or equal to x, and that is less than 1, guys. Okay, this is something else, a different inequality. And here, if you take the square of x, then what will be the interval? Again, take the square of both sides. Okay, -5 square is 25, and 1 square is 1. Which one is greater? 25. So just write the bigger one, the biggest one on the right, 25. And here, because there is a equal symbol, so it's going to be, that symbol is going to come over here. And then put here x. Always the left side is 0, guys. If one side is negative and the other side is positive, always on the left there is 0, guys. If you want to take the square of something, square of x in this case. Anyway, let's get back to the question again. So the x squares interval is 0 and 25, and there is an equal symbol here on the left, 0, and there's no any equal symbol on the side of 25. And now we're asked to find the interval of x squared plus 4. That means we're going to add plus 4 both sides, and that is going to be 4, the same symbols, x squared plus 4, and that is going to be less than 25 plus 4 is going to be 29, guys. So that is our answer, and how we can write it as an interval for is closed interval, 29 is open interval. And that was the end of this video. If you have any questions, you can put them in the comment section below. Thank you for watching, and hopefully see you in the upcoming videos.